Welcome to my YouTube channel. So, in the previous lecture of linear algebra, we have discussed about matrices in lecture 1 and lecture 2 and different type of matrices. And today I will discuss the remaining part of matrices like elementary row operations, elementary matrix, and determinants, which will help to solve the system of linear equations. So first we discussed elementary row operations. So elementary row operations are performed in a matrix. Suppose A is a matrix with rows R1, R2, Rm. So A is M cross N matrix, M rows. So there are M1, R1, R2, Rm, M rows. Then the following operations on A are called elementary row operations. What is these row operations? In row operations, between two row, some operations performed to change the matrix. So in first row interchange, in this operation we just interchange two rows, like Ri interchange the row Ri by Rj. So Rj becomes Ri and Ri becomes Rj, and we denoted this row operations by this. In second, the row scaling, that is we multiply one row by a scalar k and the new row becomes k ri. So replace the row ri by k ri. So we write this operation by this. So new ri is the k into ri. In the third operation, that is row addition. In this operation, we replace the row rj by k into ri and rj. Here the addition occur between two rows rn and rj. We multiply k with ri and rj as same, so k ri plus rj becomes the new row rj. So that's why replace rj by k into this. We write in this manner. And also one operations are there. So here if we multiply k dash with rj and we replace rj by kri plus k dash rj, where k dash not equal to 0. So we write in this manner. So this is also a row operations we will perform to change the matrix. So these are the row operations we will perform. It can be written as also ri, new ri dash is the rj, or rj dash is becomes ri. So it can be written as new ri is kri. So new ri becomes kri. We can also write in this manner. So here we can write this rj. So new rj becomes kri plus rj, and in this case we write new rj, that is rj dash becomes kri plus k dash rj. So we can write in this manner also. So this is the row operations. Let us take one example regarding this row operations. So we will perform these row operations on this matrix which is 3 cross 3, and we will show how this matrix will change under each of these row operations. So if we apply first, so if we interchange r1 and r2 on this matrix, then this becomes, so r2 becomes r1, that is 2 5 minus 8, 1 2 minus 3, and the third one remain same. So under this row operation, this matrix look like this. Here r2 becomes r1 and r1 becomes r2. So this is called interchange of rows, RIIJ. And if we apply the second things, if we replace r1 by 2 into r1, then this matrix will look like, so one row will be changed with 2 r1, that is we will multiply 2 with this first row. So this becomes 2, 2 2 is a 4 minus 6, and other will be same, 3 8 minus 13. So under this operation, that is scalar multiplication of rows, so under this row operations, this matrix look like this. And now you apply third one. If we take k equal to 1, so and ij becomes 1 2. So if we replace r2 by r1 plus r2, then the matrix look like, so r2 will be changed, others remain same, 3 8 minus 13. So r2 will be changed. How r2 will change? So we put here r1 plus r2. So we add these two terms, we put here, add these two terms, put here, add these two terms, so this will be minus 11. So under this row operation, this look like this. And last, so if we put R1 plus 2 R2 implies R2. So if we replace R2 by R1 plus 2 R2, then this matrix will look like though. So R1 will be same and R3 will be same, but R2 will be replaced with this. So R1 into 2 into this. So 1 plus 2 into this. So 4, 1, 5. This plus 2 into this. So 10, 12. This plus 2 into this. So minus 16 minus 3. So minus 19. So under this row operation, this matrix will look like this. These are the row operations, and we will apply this on R1 and R2. In this first two case, we take R1, R2, and second case Ri as R1, and here we take Ri, Rj as R1, R2. So you can take as Ri, Rj as R2, R3, and let's check what happened and how the matrix will change. So this is the example, and we apply this to operations. So now we will discuss elementary matrices. Let E be an elementary row operation, and if we apply row operations on a matrix A, then we get this matrix. And when we apply elementary row operations on a identity matrix, so identity matrix means it will be square matrix, that is n square n cross n. This will become EI and it will be represented as E, and this E is called elementary matrix corresponding to elementary operation E. So this is called elementary row operation. Whenever we get a matrix by applying elementary operation on an identity matrix, we get elementary matrix. So elementary matrix always be square matrix. So let us take example. So if we apply interchange R1 and R2 on an identity matrix of order 1. So if we apply these row operations on this identity matrix, then we get, so you can write R1 interchange R2. So this will look like 0, 1, 0, 1, 0, 0, 0, 0, 1. So this is elementary matrix corresponding to this row operation E. In other way, if we apply row operation, minus 6 R2 implies R2, that means R2 replaces by minus 6 R2. So R2 is multiplied by minus 6, so this becomes, and others rows remaining same. So this is also elementary matrix corresponding to this elementary operation. So this is the elementary matrices. Now we will enter to the chapter determinants. Today I will discuss some basic properties of determinants. Let's see what is determinant. So we know square matrix n cross n. So square matrix is a matrix whose number of rows and columns are same, so we call square matrix. So if you haven't watched the lecture 2 of this series, so please first watch that video and then watch this one. Square matrix. So each square matrix A is assigned to a special scalar which is called determinant and denoted by determinant A or this symbol determinant A, and can be written as this. So how we will find this special scalar for a square matrix A? So when n equal to 1, so that is when n is a 1 cross 1 matrix, that is A11, so the determinant of A will be this element. So this is the scalar. Whenever n equal to 2, that is A becomes 2 cross 2, that can be written as A11, A12, A21, A22. So 2 cross 2 matrix. So determinant for this matrix can be computed as multiply this, that is 11 into A22 minus multiply this diagonal, that is A12 into 21. This is how determinant defined. For n equal to 3, that is A3 cross 3, A11, 12, 13, 21, 22, 23, 31, 32, 33. So determinants will be, first take this into, so cut this and this. So these four elements will remaining. So write this A11 into this determinant of this small matrix of order 2, and then minus write this element, that is A12 into close this column and this row. So this is the first row and second column. So of second column and first row, and write the remaining element in this small matrix, that is A21, A23, A31, A33, and one element also remaining. So now let us take again plus sign A13 and write small matrix, that is this is the element at first row third column. So of third column and first row you will get these four elements and make this small determinant with this four, that is 2122 A31 A32. So how this determinant for 3 cross 3 matrix defined? So now you can find from here 1 into multiply this minus A12 multiply this minus this plus A13 multiply this and this. So this is happened. So 4 cross 4 you will get 3 by 3 matrix here instead of 2 cross 2 matrix. So whenever we find determinant of 3 cross 3 matrix, small determinant will be of order 2, and whenever we find determinant of a matrix of order 4, we get third order determinant here, and 4 element will be there in column, so another term will be added. This is the way how we will find the determinant for matrix of n cross n. Now discuss some theorem or properties. So one theorem says that the determinant of a matrix is equal to determinant of its transpose. So determinant of transpose is same as determinant of the matrix. And if A be a square matrix, then these three are true. So if A has a row or column with zeros, so if there is a square matrix, if there is a rows with zeros or there is a column with zeros, then the determinant will be 0. And second one is if A has two identical rows or columns. So if a matrix has same rows, so determinant of this matrix will be 0. Or if there is a two same column, so if there is same column, that is this column and this column same and this is not same, so this will also 0 determinant of. And if A is a triangular matrix means above or below the diagonal all elements are 0, then the determinant of this triangular matrix will be the product of all diagonals. So if d1 d2 dot dot dn, then if A is this triangular matrix, so determinant of A will be d1 into d2 dot dot dn, so product of all diagonals. So clearly this identity matrix is a diagonal matrix, so determinant of identity matrix is 1, as all diagonals are 1. So these are very important properties of determinant to find determinant of a matrix. Now we will discuss one theorem. So suppose that B is obtained from matrix A by an elementary row operation. So we have discussed 3-4 row operations. One of them is applied on A to convert this matrix into B. Now we find the relation between these two matrices determinant. First, if two rows of A were interchanged, then determinant of B is minus of determinant A. So if we applied row operation on A, that is Ri Rj, that is interchanging two rows, and we get B, then the determinant of this new matrix will be same with the determinant of the matrix A but in negative sign. And the second one is if a row of the matrix A were multiplied by a scalar k, then the determinant of new matrix equal to the scalar into the determinant of the previous matrix. So if we applied k into Ri implies Ri, that is Ri replaced by k into Ri. If we apply this row operation on this matrix A and we get B, then the determinant of this matrix will be K into determinant of A. And last one, if a multiple of a row of the matrix A were added to another row of A, that is if we apply KRI plus RJ implies RJ, that is if we replace RJ by K into RI plus RJ on the matrix A and we get B, then the determinant of the new matrix is equal to determinant of A. This is the theorem. And one another important thing is determinant of product of two matrices is equal to the product of determinant of these two matrices. So if A and B can be multiplied, then the determinant of this product matrix will be same as the determinant of A into determinant of B. So what is the benefit of this theorem? So if there is two matrix A and B and the question is find the determinant of the product matrix, then we simply first find determinant of A and find determinant of B and we multiply them and we get the determinant of AB. So without multiplying these two matrices, directly we can get the determinant of the product matrix. So this is the beauty of this theorem. Now discuss a very important theorem. Theorem states that let A be a square matrix, then the following are equivalent. First one is A is invertible. Invertible means there is inverse for this matrix A. So A inverse exists. A has an inverse, A inverse, and AX, this is a system of linear equations, has only the zero solutions, and third one is the determinant of A is not zero. So equivalent means 1 implies 2, 2 implies 3, and 3 implies 1. So this is the equivalent solution. So first, if A is invertible given, then A invertible means implies A inverse exists, and therefore Ax equal to 0, that is A is m cross n and x is n cross 1 and this is 0, m cross 1. So as A inverse exists, we can multiply A inverse from left side this equation, and from this we get this is identity matrix, so x equal to 0. So only 0 solution exists. And 2 implies 3, that if we take this, that is only 0 solution exists. A inverse exists means A inverse equal to adjoint A divided by determinant A. So determinant to be exist, this matrix A inverse, determinant of A must be not equal to 0. So 2 implies 3, and if determinant not equal to 0, then A inverse exists from this definition also. So this is the equivalent relation. So for today that's it. I will discuss more about determinants, and after that we will enter to how to solve the system of linear equations using these determinants matrix rule, like Cramer's rules, and also Gauss elimination method, and how to find inverse of a matrix. All we will discuss in the next lecture. So if you like it, please subscribe my channel and share with your friends. It will be very beneficial for the students of preparative Bhagalpur, first year BTech students, so whose course is 101. So guys, you will be very benefited by watching this series. So share with your friends and please subscribe. Thank you very much.